Number 2, stoichiometry worksheet 8 says 200 grams of HNO3 are mixed with 300 grams of aluminum hydroxide in a double replacement reaction. Let's first write this equation down. This one's a little harder because you have to predict the products on your own. So let's go ahead and write HNO3 plus AlOH3 yields. Now we're going to do this, take the positive ion from this reactant and join it with the negative polyatomic ion of this one. So H and OH, that gives us water, but it's fine if you write it as HOH. And then we're going to take the positive from here, the aluminum, and we're going to take the NO3 from this one. But we have to make sure, since aluminum has a positive 3 charge, that we write this 3 subscript on the bottom. I'm going to leave some space to balance it. I'm going to go ahead and balance it pretty quickly. If you don't know how to balance these, please make sure you ask. All right, so it says we have 200 grams of this substance, and we have 300 grams of this substance. I do suggest you always write the information. I still do. Okay, the first question asks, which is the limiting reactant? Like we did before, the first thing we have to do is we have to do 2 problems. One problem starting with one of the reactants and ending with one of the products. I'm going to pick water in this case. It doesn't matter if you pick this one. You're going to end up with the same answers. And then I'm going to do another problem starting with aluminum hydroxide and ending with water as well. Okay? So I'm going to go ahead and I'm going to do it pretty quickly. 200 grams of HNO3. Okay, now I'm going to use the molar mass. 1 mole of HNO3 is equivalent to 63.01 grams HNO3. Molar ratio, it happens to be a 3 to 3 or 1 to 1 ratio. And I got these numbers 3 to 3 from the balanced equation. Then I'm going to do the molar mass of water. Okay, and I'm solving this with my calculator. I find out that I get about 57 grams of water. This isn't necessarily an answer yet. I still have to do another problem to find out if this is the least amount of product, then this will be the limiting reactant, but we don't know that yet, so we have to solve it first. So now I'm going to start with 300 grams aluminum hydroxide. I'm going to do the molar mass. 1 mole aluminum hydroxide is equivalent to 78.03 grams. Mole ratio, for every 1 mole of AlOH3, we have 3 moles of water. And again, I got this from the balanced equation using the large coefficients. Then 1 mole of water, 2 grams. And I solve that and I find out that I would have about 200 grams of water. Now we have to look at these 2 answers. We've learned that the reactant that produces the least amount of product is the limiting reactant. So the least amount of product here is 57 grams. So this is an answer, and I want you to cross this out because this I don't want you to put as an answer for anything, and this is to remind you not to do that. So we go back and we find out that HNO3 is the limiting reactant. And we've also found out how many grams of H2O were produced. We found out that we produce 57 grams of HOH or H2O. Okay? So now the next problem says how many grams of aluminum nitrate are produced. We want to find this. And we've learned that once we find the limiting reactant, we're going to use that limiting reactant to solve for all other problems. So we're going to start with 200 grams HNO3. Okay, now we're going to do our mole ratio between HNO3 and aluminum nitrate. So for every 3 moles of HNO3, we have 1 mole aluminum nitrate. Oops. And then we are going to do the molar mass. For every 1 mole of AlNO3, we have 213 grams. Okay, we solve that and we find out that we're going to have about 225 grams of aluminum nitrate. The next question is how many grams of aluminum hydroxide are used? So now it's asking if we have this, if this is a limiting reactant and we have an excess of this, how much of this is actually going to be used? So we do it the same way. We're going to do a stoichiometric problem beginning with our limiting reactant. Kind of seems repetitive. But it's a good thing is we've calculated the molar masses already, so we don't have to do that again. Okay, so now mole ratio between, so for every 3 moles of HNO3, we have 1 mole of AlOH3, and then molar mass. Okay, and we solve it and we find out that we're going to use 83 grams. And this next question, how many grams of aluminum hydroxide are left over? Well, we've just calculated that we've used 83 grams, and in the problem it states that we started out with 300 grams. So if we had 300 and we use 83, we found out that we have about 117 grams left over. And that's number 2.